Section 9.2. The smaller the value we choose for alpha, which is the level of significance, the smaller the probability of a type 1 error, and the larger the probability of a type 2 error. Example, a test is made of the null hypothesis where mu is equal to 12 versus the alternative hypothesis where mu is less than 12. Because mu is less than 12 on the alternative hypothesis, this is a left-tailed test. A sample size n equals 50 is drawn and x bar is equal to 10. The population sigma is 5. Compute the value of the test statistic. Z is equal to x bar minus mu divided by sigma divided by the square root of n. X bar is 10, so 10 minus 12 divided by sigma, which is 5, divided by the square root of 50. 10 take away 12 is minus 2. Square root of 50 is 0.707. 5 divided by 0.707 is 0.707. Negative 2 divided by 0.707 comes to negative 2.83. So Z is equal to negative 2.83. That's your test statistic. The form of the critical region would be Z is less than or equal. It's less than or equal because H1 says mu is less than 12. So again, they have to match. Which means I set up the critical value and the test statistic. If the test statistic falls within the critical value, then you reject the null hypothesis. We'll get to that in a second. But find the critical value rounding to 3 places. So here they're giving alpha, or the level of significance, to be 0.1. So what you have to do is calculate the critical values given alpha. Notice there's really no calculations involved because alpha has different values, 0.1, 0.05, 0.02, 0.01, and it's either a left-tailed, right-tailed, or two-tailed. So for instance, if alpha is 0.1 and it's left-tailed, here's 0.1 left-tailed, my number is going to be minus 1.282. Again, this is a left-tailed test, so you reject the null hypothesis if Z is less than negative 1.282. So we calculated the test statistic to be a negative 2.83. So 2.83 is less than negative 1.282, so you reject the null hypothesis. So here you set up your critical region as a negative 1.282. All of this to the left becomes the critical region. The test statistic is negative 2.83. It's within the critical region, so you are rejecting. At alpha of 0.05, what's the critical value? So it's still left-tailed test, and 0.05 now, I'm getting a negative 1.645. So the critical value is a negative 1.645. Is 2.83 less than negative 1.645? Yes, it's still within this, so it's still rejected. As another example, a test is made such that the null hypothesis mu is equal to 19 versus the alternative hypothesis mu does not equal 19. Sample size n is 65 is drawn and x bar is a 20. The population sigma is 7. Compute the test statistic. So again, I go x bar minus mu divided by sigma over square root of n. X bar is 20, mu is 19, sigma is 7, n is 65. When I take the square root of 65, I get 8.062. 20 take away 19 is 1. When I do 7 divided by 8.062, I get 0.868. 1 divided by 0.868 is 1.15. So my test statistic is 1.15. Because this is a not equal up here, it's a two-tailed test. Because it's a two-tailed test, you select Z is less than or equal or Z is greater than or equal. Find the critical region for alpha is 0.1. So when I look up 0.1 for a two-tailed test, I'm down over here, it's plus or minus 1.645. So I put a minus 1.645 and a positive 1.645. Find the critical region when alpha is 0.05. Again, for two-tailed tests at 0.05, puts me down here, plus or minus 1.96. So it's a minus 1.96 or a positive 1.96. So I want to determine whether or not to reject the null hypothesis. Well, if it's left-tailed, the test statistic has to be less than or equal to the critical value. If it's right-tailed, the test statistics will be greater than or equal to the critical value. If it's two-tailed, it's going to be either into those regions, either it's going to be greater than the positive critical value or less than the negative critical value. So here I'm looking at just one side of this because my test statistic came out to a positive 1.55. 1.15, I'm looking at 1.645 right here, 1.645. And 1.15 is not in that region, so I do not reject it. It's not in the critical region, so don't reject it. Even when I change the test statistic to 0.05 and recalculate to 1.96, right here, 1.96, the 1.15, the test statistic still is not within that region, so I am still not rejecting it. There are 2 critical regions for each alpha, but I'm only looking at one region because my calculated z was positive. If z calculated, as an example, instead of the 1.15, it calculated out to be 2.3, and I'm still using alpha at 0.1, which corresponds to 1.645, the 2.3 is now in this region. So if it was in the region, I would reject it.